About me, as you know, my name is Satyam Patel. I'm a technical architect within SEPTA. I have 8 years of experience in integration domain. I've performed various roles, started from developer to project lead, and I've got opportunity to work in various industry domains such as aviation, oil and gas, and few others. The technology that I worked primarily when I started in integrations was web methods. It's very interesting tool. The ESPs and BPM processes over there. And it's been a while that I've moved to MuleSoft. So currently I'm serving as a technical architect in MuleSoft. Part of my role is to work with clients to identify their requirements, integration needs, come up with solutions, and all that. And yeah, I'm certified in Mule 4. I have some other certifications in Delbumi. I'm also AWS Solutions Architect Associate certified, and I did web methods when I was working in web methods. Apart from that, I do enjoy outdoor activities, something about myself. So I'm into hiking, biking, camping, yet to explore all these. That's a bit about me. So to get started, and before we start talking about the actual topic here, I thought it would be worth looking back in history, a bit about APIs, what their journey has been so far, and where we are today. So as you can see, there are 3 topics here that I'm trying to cover. So the term, we don't know for sure who invented it. It's largely considered that Morris White, David Wheeler, and Stanley Gill are supposed to be the founders of this term API. But back in 1950s, when actually people started looking into it, they only had subroutines or libraries. And it was after World War that this thing came up, that people wanted to come up with a solution to automate instructions and orders. So to execute those, they started looking into a reusable set of code, and subroutines were the starting point. After that, in that decade, IBM came up with the instruction set, and then we had C standard libraries, some other ideas around tree implementation. So that's when actually people started looking at an interface that could be used between applications to exchange data, to communicate. And this was the background about how this term started coming up. And around the 80s and 90s, there were a lot of interfaces that were being created between hardwares and operating systems. Anything that made the job easy, like to send instructions between OS or BIOS or other devices that were connected to a
yeah, so 1950s to 1990s and 2000s were the time when this term started coming up, and it's largely thought to be that the first guys who really did research into. Yeah, so the rise of APIs, the modern APIs that we know, started around 2000s, and that's when Salesforce is supposed to be the first company who launched their APIs in 2000, around Feb 7. And after that, we had eBay who came up with their APIs for eBay Developers Program. They rolled out only a select number of licensed APIs only to partners and developers. This came out around November 2000, and followed by Amazon that launched their AWS, and they leveraged APIs for exposing the services to their customers. So this was the start of APIs, the modern APIs that we know, and since everyone started realizing the value of APIs and started approaching them. So that's the decade of 2000, but then let's look at the present and the possible future. So in the present time, been a social media boom. Facebook, Flickr, Twitter, these guys, they started launching their service. They realized that the APIs are the best ways to uh, have data exchange between applications across devices and being platform independent. So we saw a large number of social media companies starting to come up, and then we had mobile apps for every business. There were banks, retails, travel. All these companies and organizations in these areas, they started developing mobile apps, and even for these, started using APIs in large number. After that, we had the rise of smart devices, so IoTs, AIs, and assistants. The common factor across all these was to have some medium, some technology to connect with each other, and the best way to what to do this was through APIs. So going further to the next slide. So where are we today? Well, APIs currently account for 83% of all the hits on internet. This is more than the HTML traffic, which is just around 17% now. Since APIs are everywhere, transforming business, and our reliance on APIs is increasing a lot. This is obviously the reason behind the traffic behind APIs. And among all media organizations are the largest users of API. This has been found by one study. And the another evidence is that large number of APIs that get published to Programmable Web, which is a subsidiary of MuleSoft, where APIs are published for the users to consume. So it's a large repository of APIs, mashups, and applications. The chart shows that uh, this started rising around 2010, 12, and it has always been going up. So there are around 23,000 entries there. This is one indication that APIs are rising at a rapid speed. What could be the reason behind it? Well, there's a sense of urgency among businesses, a rush towards having API-based architecture in all the sectors. So there's more and more competition between businesses and need for seamless integrations across industries. And like I said, the rise of IoT devices, mobile apps, smart homes, complex systems in aviation and cars, unified platform, you name it, uh, APIs are everywhere. So this is clear indication that there's increasing popularity and everyone wants to adopt this architecture. So that's about the present and the future a bit, but we don't know what the next big thing is going to be. Technology is penetrating or has already penetrated all the domains, and integration is a need. Therefore, APIs, I would say, are going to stay, or at least for next few years or decades, and internet will always be there for sure. So going further, that was the introduction about APIs. But now I want to talk a little bit about the security areas. And the reason behind this is, in simple terms, anything that is going to be popular or more exposed and more relied on is going to be equally vulnerable and will have a greater risk. Uh, in this case, it's going to be APIs. A lot of studies have found that the next big attacks would only be on APIs because APIs are being exposed a lot. So a lot of attackers nowadays, even they have evolved with their attacking techniques. They encrypt malicious code to bypass security. So the attacks and threats are evolving as well. Having said that, API security cannot be isolated or be independent from overall security of any business or organization. Therefore, I would strongly recommend that having an overall security picture or an idea about a business where the solution is going to be implemented is only going to add more value to the solution that is being built, and a lot of things will get captured or uncovered, probably be addressed well in advance uh, uh, when we are developing the solution. Therefore, I think it's important to know the overall security areas and how for a business when we are developing solutions for that organization. So largely, we all know about the 7 layers of security, the OSI model, but there's another diagram that I have on my slide here. So the outermost layer is perimeter security, also called as physical security layer. It's how you secure your data centers and all the systems over there. And then you have network security layer, which is largely to control and monitor and secure the traffic that is going in and out of a company or data center. And then you have the endpoint security. So all the endpoints that are exposed and that provide connectivity with the applications in an organization. So these endpoints need to be secure. Again, they could be proxies or there could be policies implemented at that layer to provide the security. And then, of course, the SSL implementation or um, certificates that are applied. And finally, you have application, the application that is in between the database, the data center, all the data management systems. So applications which pull out the data, uh, present it in a proper readable manner, or expose them to the external parties. So these applications are in this layer and they need to be secured as well. And then you have finally the data, the actual data that needs to be uh, properly managed. So I've classified all these into 3 areas. I would say infrastructure being one. Infrastructure security is the part of big picture here. You have to know what the architecture is, the networking and the VPCs, how the load balancers are configured or how they are secured, and what are the network controlling devices or firewalls. That would be one area. And then um, with this, you have solutions that are developed. So the solution design and structure is an important factor that needs to be considered, largely based on the infrastructure that is available. So if you have a highly secured infrastructure and if the integrations are just going to be internal to that company or network, you probably don't need too much security over there. You also need to see how you're handling data in these solutions, right? Uh, the data, whether it's exposed or it's sensitive data, or how much of data has to be exchanged through these solutions is an important factor. And then the connectivity with end systems. So the connectivity is something that is an important factor. You got to have a very secure level of connectivity. Again, depends on the requirements. And the data, finally data, how's data stored, how it's managed, and what access control or what policies do you have. What I'm trying to say here, if there is a integration or if there is a solution which is connecting to those data systems or databases, the data should not be exposed fully or should not be just available directly to these solutions. There should be some level of control over there as well. So this is what I'm trying to explain here in terms of overall security that needs to be considered. It has to work together with the API security, and something that we cannot isolate um, from the API security. So there's a big picture around here. And I also want to highlight one more thing here. It is possible that at times we probably don't need to know a lot of these things. For example, if in case of MuleSoft, if the APIs are being developed and deployed and hosted on Cloud Hub, where MuleSoft does a lot larger part of managing the infrastructure and the solution, a lot of security is already covered there. You probably just need to worry about how the API endpoints are exposed or how they're being connected or accessed. So having this knowledge adds value here. If your solutions are going to be in customer hosted environment, for example, on-prem systems or AWS and Azure, where they have their own instances, it would be a good idea to know what they have done, because the existing security that they have implemented at infrastructure level may not work fully with the MuleSoft environment. So if we are going to communicate with different teams, security teams, infrastructure teams, this would be a good knowledge to communicate in the same language. Okay, so the next part is in continuation of overall security picture. What is the general security framework that is largely followed at most of the organizations? There are a lot of standards out there. If you look, there are ISO standards 27001. There's NIST, which is a US government defined standard. It's National Institute of Standards and Technology. And there are many other compliances such as GDPR and all of the compliances. So these largely talk about how the security can be implemented at organization level. So the very basic steps here are, first is to identify the security needs. What it means is you have to assess and strategize, knowing your environment, what you require and what you don't require, and what vulnerabilities and possible risk areas. When you know this, you can move on to the next step, come up with a strategy to protect your systems and implement and secure them. Have that, so the organizations know what they have to protect. They have identified these areas, and they have implemented their security structure. The next step is, of course, to actively monitor and have intelligent monitoring in practice over there. So uh, this would largely be monitoring the traffic and um, what's going on there. If there's any suspicious activity, like large number of requests, or if there are a large number of failures, there has to be some sort of intelligence behind it, um, by accessing the logs or audit logs and where the traffic is coming from. So all this would help an organization to detect any sort of suspicious activity and respond to it. And that's the next. Once you know about this, to mitigate the vulnerabilities and risks and what improvements can be brought in. And finally, it's the same step here where you see recover. So you have all the improvements and all the vulnerabilities are, and there's a plan and improvement in place. So this is a circle that is a continuous circle, and it keeps it's a continuous activity at any organization. With that, I'd like to go ahead with some examples of recent breaches. So if you see on the screen, the incident of breach that I'm trying to show here is for a popular food outlet, Panera Bread. This was brought to notice by one ethical hacker who tried to access Panera Bread's URL and tried to access data of all the users that were customers of Panera Bread. And as you can see on the screen, it was a very simple attack for him. He just had to hit the URL and he could get all the users' data, like their email address, names, credit card numbers. This is just an example of a poor design of an API. But the good thing is at least the credit card, so they were not directly exposed And this is one type of attack. It's just that it could be how the attacker would have to get access, bypass all the security parameters, and he's trying to abuse the type of breach. I would say this is reported by one of the hackers, and he informed the company that they should take some action towards it. And first of all, nobody believed him, and later it was found that they tried to fix it and even publicly acknowledged that it was just few thousand records. We don't know for sure what happened, and obviously, no company is going to disclose what was wrong with their security structure, what was wrong with their core, and that's one of the things that never gets out. But this is an example of how a plain simple URL was used to get uh, details about users and largely customers. What we can see here is there probably may not be a direct revenue loss, or people might not get dropped off their bank accounts, but having these details out in market in public, and probably these can be used in any way, like these details can be shared or sold to a competitor, or they can be used to harm in some other way. Okay, so I'm going to go ahead. I have a few more examples like this. So the next one that you're seeing on my screen is probably you might have all heard about it. So this was about Facebook leaking around 50 million user account details. And this occurred around last year, not last year, last year, around 2018. Uh, so what happened here is the story behind this is that the attackers got access to the access tokens of user, and this was largely a flaw in one of their code, which was a mistake of a developer. So the attackers were able to get the access tokens, and they were able to use that to access the accounts of other users, and they had full access. They could even post content, they could modify settings, they could delete the accounts. It was one of the largest breaches for the company. It was also officially acknowledged by Mark Zuckerberg, and they acknowledged what was wrong with it. And of course, they did not fully disclose what was or how was the attack executed, but then we know a bit about it. It was largely because of the access tokens. And access tokens are a popular way of securing APIs. They're used for getting access to APIs and processing when you're processing the request or sending a request. So that is one story about Facebook. And the other one that you see on the right side is not an attack on Facebook, but their account was hacked on Twitter, and this was done by uh, some some group called Armine. So this is again a popular way of providing service there. Like, hey, we've got your account hacked. If you want to secure it, reach out to us. They did not expose anything, or they did not uh, harm in any way, but then they're just exposing even the biggest companies. They have some flaws. They are not secured uh, fully. This would be an example of harvesting access tokens or abusing access tokens. Um, you would understand more when we talk about the API threads, and that will help you relate to what these attacks were and what were these type of what were the threads. Yeah, and there's an interesting story that comes to my mind. We all would have heard about stories going around that Russia could have been involved in rigging U.S. elections, and there's no direct proof about it. But there's a lot of investigation going around it, and they say that Facebook was used for it. Uh, Mark Zuckerberg was also called and questioned for this by special committees in US. And you might also have seen some shows around it, like Netflix show about social dilemma. What it means is Facebook can largely be used for influencing people, promoting propagandas, and the way it can be done is because there's an AI behind it, and AI can be tricked. So if you try to relate this with this attack, where attackers were able to access user accounts of around 50 million users, they could have done a lot of things. They could have posted content, or they could have liked or disliked pages. The AI behind the Facebook. So it's just another way of causing chaos. Um, yeah. So we'll go ahead. There are a couple of more examples. Capital One, again a popular credit card company. They got hacked. They got their 100 million user accounts were exposed, and this happened last year. So 100 million user accounts in the US side, but they had around 140 social security numbers and 1 million Canadian social insurance numbers. Very sensitive information was out in the market, and we don't know how it could be used. The recent news that came out was they were asked to pay $80 million in fine for this attack or for this breach. So apart from other losses and side effects, like their shares were also driving. They had to suffer a huge loss in financial area by paying fines. Okay, and there's a long list of these pages. There's Equifax and Marriott. They also got their user account details exposed. So there's endless news around this area. With that, I want to talk a bit about some of the reports and trends. So on an average, there's 7.9 million cost when there's a data breach. The amount of time it takes for these companies to detect that there was a breach is something around 196. So this was a study conducted by IBM Intelligence, and they studied the uh, recent breaches and how they were uh, tackled, and then they found that 95% of all the data breaches were because of human error, which is acceptable, which is understood. It has to be because of the flaws in code or development, or in the overall security structure. So there had to be some flaws which were leveraged by the attackers, and they were able to get in and cause damage. Um, yeah, and 65% of the top 100 banks, they failed web security testing, so which is an alarming percentage. Uh, then on the right side, you see there are top 5 cybersecurity threats. I'm not sure if you're able to read it, but the first one is malware. Uh, so this is some sort of code or software that is being passed to cause damage without owner's knowledge. And then you have web-based attacks. So these are on number 2, and largely there are APIs involved here. And then you have web applications or injection attacks, again, very popular. Phishing attacks and DDoS, which we all know. These are just to make the APIs unavailable, or not APIs, but any service or any applications, just denial of service. So these are the top 5 cyber threats that have been identified. This was a study done by European Union agency, and that's pretty much the background about how what's coming in and what's going on around the integration areas, and largely where we have APIs today. So with that, I want to move ahead to API threats. So security of APIs, for that matter, any form of integration is not isolated from overall cybersecurity. And I don't believe there's any Bible out there or any document which says if you do these things, your APIs are fully secured. But knowing the vulnerabilities, or knowing your environments, and knowing the data that you will be handling through APIs is one step towards knowing the possible threats and how to counter them. So you must have all heard about Gartner, which is a popular company that studies integration platforms and creates a lot of nice reports. Uh, they say APIs will account for 90% of the attack surface, and API abuses will be the most frequent attack vector. So the biggest risks are associated with financial organizations, and which are still on legacy systems, which are still heavily relied on, mainframe-based systems, and are rapidly moving towards APIs and revamping their IT infrastructure. There's also a shift towards PSD2 and open banking, and financial institutions have to make their APIs publicly available, which is again uh, exposing their systems to the threats out there. So here are some of the REST API security threats. The most common ones, the most popular ones that we know are there, and these have been the reason behind all the recent breaches for most of the companies. The first one is the injection attack. What it means is a malicious code, usually a script or a query, is embedded in the request to trick the code and to get more data than it is intended to get. An example of this, as you can see on the screen, is there's a URL and a user ID is being passed, but the attacker is also passing a query over there, or 1 equal to 1, and in return he gets not just details of one user, but he's going to get all the user data. This is possibly what would have happened with Panera Bread, uh, because they did not uh, validate the parameters that were coming, or validate the payload that was coming in, and they just exposed all the user data out there. And the next one is the man in the middle attack. Again, it's a very known and a common way of cyber attack. So an unauthorized third party secretly relays and possibly alters the communication between two parties. So it just creates a distrust. It does not even create a distrust. These parties don't even know that they are being monitored or someone is listening to their traffic. Uh, and without them knowing, this attacker is going to get control of important details. So he's monitoring the message that is being transferred between these two applications, and he's going to read out what's going on. He can even alter the data, or he can use the data, and there could be sometimes sensitive information over there, such as payment details or account details. Uh, so that's one. And then you have cross-site request forgery force attack. So this usually would be some sort of code, or making users to open URLs, or even send requests without them knowing that they did something unintentionally. What it means here is the user's browser and the web server, they are already connected. There's already a session established over there, but when the payload was written from the web server to user, an attacker just passed in some other code in there, and the next time user's browser communicated with web server, this code was just posted, and web server thought this came from the user's browser. So the attacker just simply used the credential, the valid uh, access that user had, to bypass and get the code run, get his work done. And the next, I hope you're able to see my screen. So next few threats that I've listed here are the broken access control type of an attack. What an attacker does here, he's trying to bypass the authentication mechanism that is already in place, and just use his own access to get something else out of the end system. So if you see the image, there's a user here, and he has a valid access to the end system. Uh, Instead of passing his own user code, he's passing some other random user code, and he's getting details about some other user or user 123. Just an example to explain how uh, the attackers can bypass the authentication methods. Uh, he has a valid access, but he's able to get data that is not intended for him. And then distributed denial of service. This is one of the most common type of attack. Uh, the attempt here is made to block all the resources, uh, disrupt normal traffic by flooding requests to target system, and this leads to breakdown of APIs. So an attacker will have some bots trying to hit a URL, and this will essentially block all the traffic going towards it. This is not a valid traffic, but other users will not be able to get in. Web parameter tampering. Uh, so based on so this is based largely on manipulation of parameters. These are query parameters and a URL or a request that are exchanged between client and server in order to modify application data. So this is also one of the examples. This is also one of the ways where user or an attacker, sorry, can manipulate the queries and get data out of end systems. Sometimes they're going to combine one or two of these threads to get uh, unauthorized access to the systems and cause damage to them. And the last one is the sensitive data exposure. So this is when the data is not encrypted, that is being exchanged between a user and any system, or if the data has been returned to a log file. This is just a poor design. If you're logging sensitive information in log files or any other place or any system, an attacker is simply going to need to get access to this place or log file, and this would lead to leaking of private information. This could be any information, could be credit cards, it could be health information, emails, phone numbers, or anything. Sometimes a lot of data from payload is locked for various reasons, and this is how sensitive data sometimes get exposed to an attacker. It's just something that can be even handled just by a good design or following best practices. Okay, I'm going to go ahead. So with that, those are some of the API threads, some of the most common ones that are there out and most often talked about. Uh, by knowing all this type of data breaches, type of attacks, it gives us a good understanding now what needs to be done for API specifically, and even in the uh, larger picture, how to fit the security solutions when we know how the infrastructure is and how the security structure is at an organization. So security has to be seen as a design principle. It shouldn't be one person's job, or it shouldn't be one department's job. Not security team alone can completely secure the environment, right? It has to be the developers, it has to be the code, it has to be the entire organization has to work together to make it possible. So here are some of the security building blocks, and these were again consolidated by Gartner based on um, all the threats out there, all the attacks and the data breaches. Uh, so as you can see, authentication of the API clients, authentication of end users, traffic throttling, content inspection, uh, securing the communication through SSL, or securing the data that's being exchanged through encryption and decryption mechanisms, and then storing audit logs for monitoring and finding out if there are any suspicious activities. A signature validation is again a good way of ensuring that the message was not compromised while it was being transferred. You also have API key management that you should consider when you're looking at the overall security picture. And then there are tokens that can be leveraged: OAuth, JWT, uh, and third-party identity providers. All this together are going to help achieve overall API security. So these are seen as security blocks. Uh, this is one thing that we should always have in back of our mind when we are thinking about a solution on how to secure APIs. And I wanted to bring up this uh, slide here, some industry standards and compliances which are around the APIs, and now is largely being used for integrations across industry domains. So there are so many standards out there. There are governments, there are banks, uh, there are other agencies who are coming up with these standards and compliances to make sure that security is implemented uh, properly. So the first image that you see is the compliances, GDPR, which is a European compliance, and then you have ISO 27001, then the payment compliance PCI, and you have AICPA. A MuleSoft platform is compliant to all these standards, and MuleSoft platform, by that I mean the Cloud Hub platform, which is hosted on AWS, is compliant to all these standards. So it takes care uh, of some of the security requirements for organizations who have this requirement. Then you have PSD2. So if you're dealing with European banks or uh, building integrations for them, they have to comply with PSD2 payment services for exposing their systems for integration purposes. And then there's a European Banking Authority. So this is a group that works on API standardization under PSD2. PSD2 also defines a lot of other uh, standards. And you also have the Government of Canada standards on API. So government has listed out all the standards. It's a very good page which describes how the APIs have to be designed, how the APIs have to be secured. If you are building solutions for the Canadian government, uh, so this shows that everyone is getting more aware about the APIs and the security requirements around it, and they know APIs are going to be there, and with that brings a lot of risk and vulnerabilities as well. So it's just stressing the importance of having best practices and standards. So with that, I'd like to go ahead with the API security best practices. So the first one is enforce secure communications, which is a very basic requirement, largely being followed in most organizations. So no matter what the organization is, what the data is being handled, you gotta ensure that these communications are secured, and this can be done through enabling TLS 1.2 or any other versions that come after it, following the CSE guidance. And that's one. And then the other one is designing APIs to be resistant to attacks. So if we have a good API design, uh, which can avoid common attacks like SQL injection, right? Validating data beforehand before it's being processed. So if the data is suspicious, it can be stopped right there, and the attack cannot make through. So having a good API design, considering all the factors like what the environment is, what's being exposed, and the data that's being handled, will ensure that APIs are protected against some of these attacks just by having a good design. And avoid putting sensitive data in request URLs. I'm sure everyone is aware about this. Every organizations, nobody wants to expose sensitive data in URLs, but URL strings can be tracked and compromised. So if this is something that you want to avoid, naturally you don't want to pass any sensitive information either through query parameters or anything in the response. And protect access to APIs. So before the APIs even process the data, you got to protect access. API should not be accessible to everyone and anyone out there. You have to have a mechanism to authenticate and authorize before any operation. There are ways to do that, and you can also use open standards like OAuth2 or OpenID Connect. Yeah. So continuation of the best practices, use gateways and proxies instead of whitelist. Whitelisting IP is a very common way of restricting internet traffic, but it's not the most advised or most secure way of doing it. You should either have a gateway server, probably in a different network, or a VPC. That is the first layer where API requests are hit. You can have your proxies, API proxies deployed over there, and then the actual APIs in a secure network. So avoid using simple techniques like IP whitelisting. Rather go with gateways or some other form of traffic controlling mechanism. And integrate security testing. So we do a lot of testing for APIs. We do unit testing, performance testing, load testing, but I'm not sure how many companies actually test for security of APIs. So this is something that has to, become part of normal practice, that API security has to be, automated. There should be some predefined test for any API that's created or any changes that are made to a code. This would be one way to make sure that no other vulnerabilities were introduced in the code. And audit access to sensitive data. So if APIs are dealing with sensitive information, it has to be logged in audit. And these audit logs should be reviewed time to time to identify if there was any suspicious activity, if there was a more than required data being fetched out, or more number of requests to this sensitive data, that would indicate that there's something wrong here and there should be some action taken here. Periodic audit of APIs may be required depending on the nature of data and its usage. And then you log and monitor for performance and activity. Uh, this is again a very common way of knowing if there's anything wrong with the implementations. So usage should be tracked for any suspicious activity. And what this would mean is if there are large data requests, or if there are after-hour requests, or if the requests are coming from unknown geographic areas, like not the normal ones. So having some intelligent monitoring there to detect these suspicious events can help protecting the APIs. And then we have some more best practices that I've listed here. So like we discussed already, so the identity of user and app should be uh, authenticated, and then you have API communicating with the backend server system. Even these have to be authenticated, and user and app authorization should be done. So identity is the core of the security, you must be able to recognize the apps that consume your APIs or users of the same API or the servers that APIs are calling. APIs should be able to identify themselves as well to apps and servers, and this way there's a mutual trust and secure communication established between users, app, and the backend system. And then you could also leverage identity providers. So having single sign-on for multi-experience or single experience. These are some of the ways how you can leverage identity providers. You can also have W security with SAML assertions, and like we already spoke about OpenID, Connect, and JWT ID tokens. So you can see on the image on the right side, a user is trying to log into an app. User just has to log in once, and after the user is able to log into the app just connects with an identity provider to get an access token. Using this access token, the request goes ahead to the actual API, and then the data is written back to the user. What this helps is the user doesn't have to use their credentials again and again. It's just once or twice when they have to get the token, and tokens have expiry dates. By this, we are limiting the number of username and password credentials being exchanged over the network. And therefore, it's a better way of securing communication than just using username and password every time. Okay, so then the next part we spoke about is message integrity. So it goes beyond the authentication of app and user, and how you can do this is by having digital signatures. Uh, so messages that are digitally signed are thought to be that okay, this message came from app, and the API also knows that this is a valid message and it was not tampered with. So this is one way of building trust. And to ensure messages are confidential, you can have them encrypted using public keys, digital certificates, and manual authentication with digital certificates, and also using the HTTPS protocol. The last part and the best practices is about the API availability. Largely, this translates to having a reliable architecture. So the APIs, uh, they need to be, even if they are under an attack, if an API is not, the structure is not designed. So how do you achieve API availability is to have API spread across number of instances, or have multiple workers uh, that are available and have APIs deployed on them. So this is one way to ensure that APIs are available. Okay, so the next slide is about design considerations, few design considerations. So we've spoken about this in the previous slides a bit. Knowing what the data is being handled, know the data, or you should always know what data is being handled. But if you're designing a reusable API, you don't want to expose all the data from the end system to the uh, user or another system, just to make it more flexible or more usable. The data should only be shared as much as required. And if it is a sensitive data, it has to be masked or encrypted, or you need to find out how to share only required data. Sometimes you can even tokenize these uh, information, so they're not shared in raw format. And when accessing end systems, again, this probably may be out of our control. But if you're accessing end system through APIs, you don't necessarily need entire, full access. You don't need access to all the tables, or if it's a database, or access to all the files or on that location. So whoever is providing this access has to be made aware that you just need what you require for this integration. So this will also limit the risk and it will also protect the data that is being shared across. Then temporary storage of business data. Ideally, you should store data locally. Like we saw in one of the slides, that an attacker could just go and look into the log files or look into the payload files or anything over there and get access to the information from there. So if at all it's required, it should be cleared as soon as this data is processed. You also have object stores, which are largely used for sometimes storing um, information that's required very frequently, but it's advised that you shouldn't have sensitive information in the memory, again, which can be easily accessed. Okay, now that we've spoken about all the API security threats and ways to secure APIs and what are good designs, we're going to look at how we can do this through MuleSoft with all the tools that are provided and all the features that MuleSoft provides. So we have API manager, the secret manager, access manager is there. Lots of monitoring dashboards and tools or ways to create custom dashboards. There are alerting mechanisms. So there are ways to set up alerts from API manager or from runtime manager. These are some of the features. And then you also have the ability to externalize logs for analysis. Uh, these are important features that MuleSoft provides. This is the next step after we have, let's say, secured the APIs. We've implemented the solution, but then we also want to monitor if at all anything's going to go wrong with these APIs, of if they are under an attack or if they're being abused. So by using these tools, we'll be able to capture these unauthorized activities and take steps from there. So an API manager, as most of you would be aware, provides the ability to configure API policies. So there are default policies that MuleSoft provides, which are ready to use, and there are automated policies that will be applied across all the APIs. And there are custom policies as well that you could create by yourself. What these policies are, we're going to look in a moment. But these policies are largely uh, they are across security, compliance, transformation, troubleshooting, and quality of service. It's not just that the security policies are important here. Even the compliance and quality of service policies will help, prevent and add additional layer of security to the APIs. So these are some of the security policies that I've listed here. Strongly encourage that everyone has a detailed read through of these policies or even do a quick POCs how you can leverage this. Some of them are pretty simple to implement. Once your APIs are ready, you can just go to API manager and implement a few of these, but a few would require you to edit API specification, maybe YAML for example, if you have to implement client ID enforcement, or if you want to add something in the header part. So security policies are for basic authentication that would authenticate LDAP credentials. Then you have single user password, IP whitelisting, backlisting, again, very common ones. JSON threat protection will be a policy where you're dealing with JSON data in your API request. So to limit any sort of attack through JSON payload, this policy can be used. And then you have XML threat protection policies. Again, if there are nested XML elements or something wrong with their XML payload, can be used there. And client ID enforcement, this is just going to enforce a user or client to pass credentials when they're making a request. And JWT policy is going to make sure it validates the JWT token that's being uh, passed along with the request. And then a few more here. So OAuth 2.0, access token enforcement, using Mule OAuth provided policies. So Mule also provides the service where you can enforce tokens in the request, and the MuleSoft service will validate them. And you have OpenAM access token enforcement, the ping federated access token, the ability to tokenize and decode tokenize sensitive information in the payload. And then there are a few other policies that we talk about. So there's a couple of them in the compliance area. Client ID enforcement is a compliance policy. Then you have CORS that enable calls executed in web page to interact with resources from different domains. The the QoS policies such as rate limiting, spy control, caching, these can also act as an additional layer of security when you're trying to control unauthorized requests or traffic that is coming from internet. And then you have message logging facility. So if you want to log custom message when an API is invoked, this policy can be used for that. Going further, so we looked at the API manager policies, the different monitoring dashboards that MuleSoft provides. A lot of them are there. Let's say if you want to monitor the traffic that is coming from some areas, some geographic regions, you can look into that, and then there are ways you can see how many requests were made or how many requests came in, and then what was the average response time, and if there are any API alerts that are getting triggered or for some reason. So all these things will help in identifying if there's any suspicious activity going on there. So it's a good idea to leverage these components that MuleSoft provides. Thing to remember, most of them, all of them would work if you're on Cloud Hub. You might have to see what works if you have an on-prem environment or you have a customer-hosted cloud environment such as AWS or Azure. It also depends on the subscription that you have. But these tools are available in addition to any external tools that you might have. And talking about the API Manager alerts, so the alerts that can be configured on API Manager are these. For any policies that get violated, it will send alerts. If the request received by API exceeds the given number within a period of time, so this is basically to limit the traffic. If getting large number of requests, it will send out an alert, and then there are alerts for any HTTP error code or if the response time exceeds certain amount of time. These are some of the alerts that can be configured on API Manager. And I also want to talk about the API event analytics and forwarding. So you could also have these setups. So this will show request by date, by location, application, and platform. This can help in identifying what's normal and what's not normal, or what's wrong, and to detect any suspicious activity. There's also a feature here to externalize analytics data. So it can be done in two ways, by using the analytics report API or forwarding the API analytics events. So the screenshot below shows how it can be done. Just have an API in the properties. You just have to go and set up the URL where you want to forward the API event analytics. The next part is the runtime manager alerts. So these could also help in detecting any suspicious activity. If there are a large number of errors, if there are large number of new messages. If the response time is longer than usual, and and you can also export runtime manager logs to external analytics tool through the plugins that are provided already. So these are all the ways that we can do. We can achieve API security. Uh, it is like the design, it is the policies, and also monitoring and detecting if there's anything going wrong there. Uh, the big question after all of this is, have we achieved API security? How do we know that APIs are truly secured? Um, it's something that you have to see. So one thing is to have the APIs tested for the security, but you can also have the APIs attacked by some professionals or some companies who are specializing in this. You could try attacking APIs yourself using some tools, vulnerability testing tools to test policies, or you can do some basic tests by yourself. You can involve the organization security department to test the code and environment through their standard practices, and then of course come up and advise them to have regular penetration testing uh, done. So all these ways would ensure that the APIs are truly secured, because largely most of the organizations do not perform security testing for their APIs, and it's one of the most effective ways to know that APIs are protected. Um, these are some of the security testing areas. So you could have your APIs tested for credentials, authentication, authorization session, privacy, data certificates, and all that for the data, and even tested from the network layer or from the physical layer. This will help knowing if there's anything wrong and if there's anything that has been missed. So finally, I want to conclude the presentation by summarizing what we've seen so far. So it will be good to know the big picture, the infrastructure and the business. The security comes at a cost, so whatever we try to implement will have additional cost. It will have development cost, implementation cost, testing cost. So there will be some side effects as well. If we have a truly tight, secure environment, maybe it might not work for some other things. So the ideal way is to recommend and do what's needed and what's right based on the circumstances, based on the organization, the business, and data. Uh, Security is a building block. There's no one way to do it. So it totally depends what you can use and how you are layering it and how you structure it. Finally, it's important to get it tested for security some way or the other by either asking the organization's department or telling them to have them tested for penetration, and trying to get them attacked in a way to detect any vulnerabilities. It's not a one-time activity, so what we probably might have developed a couple of years ago might not be truly secure today. Uh, Something that has to be revisited again and again to see it's still doing its job, and always leverage proactive monitoring and implement policies which are available, at least from the MuleSoft side. Follow the best practices and be as restrictive as possible in API design. And finally, uh, to discuss in the community, let MuleSoft know for additional support if there is a specific use case and it requires solving or providing resolution in the platform. So with that, I would like to thank everyone for investing your time and participating. I hope the presentation was worth your time. There's something we all would have learned from that. And with that, I just want to hand it over to Alex. And if there are any questions or any ideas that people want to discuss, we can do that. Just sharing a few links here. It's a link to my blog, a link to my LinkedIn. I'd love to connect with you all. And if there are any feedback and suggestions you might have, please leave it on this form that I've created for myself.